computer. Yeah, I'm recording that. Okay.
Sure. So the initial conditions are set right here.
Okay.
In this here thing called, yeah, in this here. So basically what I'm doing for my code is, this is better. I hope this works. I fixed it last time, but it might not work this time. So basically, the fact that I put this in, I put the initial conditions as a first data point means that it's going to start like where the it's going to start where the data starts. Yeah, so then it runs, and it should plot eventually. Yeah, sometimes it takes a while. Oh wait, no. Well, I guess yeah, sure. So when I start at the initial point, well, in this case, this is a bad example because the initial point is just equal to 1 and equal 0. But if I were to go to a different one, right? So basically, what I'm trying to say is, over here you would change your initial conditions. If you want to go for the typical ones, then you would do 1 equals that, 2 is 1, and you keep on going. So you would change them right here.
Okay, so I am a little bit confused. So it's like what's in that parenthesis? Like 1, 2, 3, 4 means?
Oh yeah, so here's for A. This is for SM. This is for B, C, and D.
Oh, okay.
Yeah, so this is A, SM, B, C, D.
And this like
And
when
you
it
just
says
change
like,
it here.
okay, so when you say it's equals to 0, like 1, what does that specifically mean there?
So if I were to run the, wait, one second. If I were to run this code again, and we see the plot, are you seeing the plot or not?
I cannot see the plot.
Okay.
Are you sharing the whole screen or?
Yeah. So here,
Yeah.
the initial conditions are over here for the 1 and here for the 0.
Okay, I see.
So like the first, so in this case it's a bad example, but the first data point was, so like the first data point for A was equal to 0, for SM it's equal to 1, and it goes like that.
Oh, okay.
And,
I see. Okay, I
right.
see what you mean.
And like let's say I were to use some other initial
Okay.
file.
Okay, so I can say like whatever, like the C0 equals like 1 point.
Yeah.
Like
It can
0.8 something.
be pretty much whatever.
Okay, gotcha.
I'll show one example. Yeah, so now I change the file. So the initial conditions, they just go here. But because I was lazy, I just made the initial conditions a first raw data point at 8 minutes. So that's how that worked. And if I were to run the same code, but for a different data set that you gave me, this is still a bad example. So I'm not sure why that's a bad example. That's a bad example. Let's go with this one. Yeah, so if I were to run the same thing with a, if I were running the same thing with a data set that doesn't have the initial data points at 1 and equal 0, we get something like this, where they don't start at equal to 1, equal 0. They start at different places.
And like how this line is generated, is that like a specific order of fitting, or like, or it's I don't know. Is there any default setting for this line, like exponential or polynomial? I don't know.
So like the curves,
Yeah, like curve,
the curves are generated numerically.
numerical. Okay.
Well, you could technically find an analytical solution to it, but I get them numerically.
Okay.
ODE 45. I mean, you could.
Sorry. Yeah. So I think like the k value we want to get is it's depend on this curve.
The curve depends on the k value.
Okay. Gotcha.
The k values are just trying to minimize the sum of squares.
Okay.
So the sum of squared. Well, so we get our optimal k values by minimizing the sum of squared errors, like as in a least squared regression.
Wait,
Then using these k values, we use ODE 45 to generate the curve.
Okay. But like
You could also just you
Oh,
could also
yeah.
do the same thing numerically, or you could also do the same thing analytically, but that's hard.
Okay. But like, how do you get the activation energy from this k value if this k value is not analytical, but like numerically?
The k value is optimized. It's just the best fit.
Okay. So it's not relevant to the.
It's an observed k value. It's not an intrinsic k value.
Okay, so that's not relevant to the activation energy.
Observed k values are right. I mean, yeah, it's not directly relevant to activation energy.
Okay.
But the assumption we're making is that the observed k value is equal to the actual k value. That's the assumption we're making.
Okay, gotcha.
Like it's already very suspect that we're doing. It's already very suspect that we're assuming everything is equal to a pseudo first order reaction, right?
Yes. Right.
So already the activation energies that we're getting are wrong. The k observed rate constant is the best fit rate constant that we get, assuming pseudo first order kinetics.
Yes, right.
So activation, right? So the values we're getting for activation energy are just already very suspect.
Okay.
So hopefully that answers the question.
Yeah, that sounds like my question. Okay. And yeah, I already installed that add-on. The code can run now?
Is working?
I'll share my screen. Can you see that graph right now?
I can see it. Yeah.
Yeah, so it can run right now. So I just have another questions about this initial condition we just talked.
Yeah.
So like as like you can put more like something like initial condition like that blah 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 something or something right here. Like why you still need to put this two line?
You don't.
Like I can delete that two lines, right?
The first line is needed to initialize the array.
Okay.
The second line is only to make the initial conditions equal to the first data point.
Okay, so like this line, when if I enter this line, I don't need to enter enter this line. It already matched the first data point we have, right?
Yeah, but if you want to input your own initial conditions, then you have to remove that line and then add your own and then add your own conditions.
Okay, I need to remove this line. You mean, right?
If you want to, yeah.
Okay, so I don't know what's this sign is mean to.
Yeah. So the raw data is a matrix. So the colon just means take all of the columns from that matrix. So basically it means it's trying to take the first row and all of the columns from the first row.
Okay, gotcha.
That's what that means.
Okay, and this one just means
the first row.
The first row, okay.
And the first row is the data at time t equals 8 minutes.
Okay,
That's how it was. and I know that because I made the spreadsheet like that.
Is that this one?
Yes. So if you go to the first spreadsheet,
Whatever, just like this one.
yeah. So the code will read the matrix from the first one here, which is wait no. Could you go even more to the left? Yeah. So the code will read the data from the first sheet,
Okay,
and
so
and in this case the initial conditions it is using come from the first line.
okay, so that one means like first sheet or
No,
first
it means
row.
the first row.
Like how you define the first sheet?
It just automatically takes from the first sheet.
So like if I want it to take the data from the second sheet, how I
You would
wanna?
have to move the second sheet to the first sheet.
Oh, okay, so it cannot distinguish the different sheet, right? Okay,
It can, but I didn't program that.
okay, gotcha.
I'm sure there's a way to do it, but I didn't do that.
Okay,
It just takes the first one.
okay, gotcha. Okay, I think that's all my this one.
Oh, and then if you go to PPE disassembly ODEs,
So
you would have to change the to implement your second model. You'd have to change the rates here.
like which one? It's the like the R.
Yeah, so you would have to change. Well, you would define R as a rate,
Mhm.
and you would have a list of R's, and then at the very bottom, the change in the concentration is equal to the sum of rates. Right. So you would just have to change this. You would have to change the entries in the file here to get the more advanced model.
Okay, like if I don't want to have the pseudo first, I need to change the thing here to.
I thought we were always doing pseudo first order, even for
Okay,
the more advanced case.
yeah, but like, what's the thing you're talking about? Like, if I want to go, if we want to stick with this, it's like I think we just stick with the model. I don't understand like what's the thing you're talking about
Oh,
this.
so the code here is only working for the simple model that you told me to do.
Yeah.
If you want to use the more advanced model, you'd have to change these
Oh
values.
yeah. Okay, I got you what I mean.
Yeah.
Like the second model we talk about.
Yeah, yeah.
Okay. Yeah, definitely.
The code here only works for the simple one.
Yeah, sure. Okay. Okay. Cool. I think that's all the questions.
Hopefully that helps.
Yeah, that definitely helped me. Okay, cool. Thanks.
Sure.
See you.